We are discussing the CSIR NET Physical Science question paper of June 26, and we are solving quantum mechanics problem in that paper. This problem is related to particle in a one-dimension box. The state of a particle of mass m in one-dimensional rigid box in interval 0 to L is given by normalized wave function. If its energy is measured, the possible outcome and the average energy are respectively. So we have solution. We have psi x is equals to root 2 by L 3 by 5 sine 2 pi x by L plus 4 by 5 sine 4 pi x by L. So psi x can be written as 3 by 5 root 2 by L sine 2 pi x by L plus 4 by 5 into root 2 by L sine 4 pi x by L equals to 3 by 5 phi 2 plus 4 by 5 phi 4. Further, if a measurement is carried out on the system we would obtain Kn is equals to n square pi square h square by 2m square with corresponding probability. So for state phi 2x E2 equals to h phi 2 give us 4 pi square h square by 2 ml square equals to h square by 2 ml square, and probability is equals to phi 2 equals to 9 by 25. Similarly, for state x E2 E4 is equals to phi 4h phi 4 equals to 16 pi square h square by 2 ml square equals to 2h square by ml square, and probability of E4 would be mod phi 4 psi equals to 16 by 25. The average energy is equals to summation pi ei equals to 9 by 25 E2 plus 16 by 25 E4 equals to 9 h square by 50 ml square plus 64 h cross square by 50 ml square is equals to 73 by 50 h square by ml square. Thus, our option A is correct for this problem. This problem is related with the commutator of angular momentum components. So, if Lx, Ly, Lz are the component of angular momentum operator in 3 dimension, the commutator operator of commutator Lx product of Lx, Ly, Lz is simplified to. So, solution, we have Lx cap into Lx, Ly, Lz. Now, we would be using the identity Lx, Ly, Lz plus Lx, Ly into Lx, Lz, which is equals to IH cross Lx into Lz square minus Ly square, where we have used Lx, Ly equals to Lx, Ly plus Ly equals to Lx IH cross Ly IH cross Lz, and further Lx, Ly commutator of Lx, Lz equals to Lx, Ly commutator of minus IH cross Ly equals to minus IH cross Lx, Ly square. So we have substituted this value here to get this result. So our option is correct for this problem. This problem is related with the hydrogen atom. Suppose that the Coulomb potential of hydrogen atom is changed by adding an inverse square term such that total potential is VR Z square by R, G by R square, where G is constant. The energy eigenvalue NLM in the modified potential is. So, solution, for a stationary state in central potential VR, wave function is given by psi NLM and energy is given by ENL. Only for hydrogen atom when VR is equals to minus ZD square by R. Energy depends only on N due to Coulomb degeneration. A term like G by R square is like L into L plus 1 by R square. This centrifugal barrier thin term given rise to L dependence of energy. Thus, our option A is correct for this question. The eigenstate corresponding to eigenvalues E1 and E2 of a time-dependent Hamiltonian are 1 and 2. If at t is equals to 0, the system is in a state psi t is equals to 0, sin theta 1, cos theta 2. The value of psi t at time t will be. So, solution, we have psi t is equals to 0, sin theta state 1 plus cos theta state 2. The wave function at time t is given by psi t equals to sin theta 1 e to the power minus I e1 t by h cross plus cos theta 2 to minus I e2 t by h cut. Applying normalization condition, we get psi t equals to sin square theta state 1 1 plus cos square theta state 2 2 sin square theta plus theta equals to 1. This problem is related with the time-independent perturbation theory. Here, consider a particle of mass m, Vx is equals to m omega square x square plus g cos x. The change in ground state energy compared to the simple harmonic potential is 1 by 2 m omega square x square to the first order g in g is. So, Vx is solution. We have V of x 1 by 2 m omega square x square plus g cos x. Hamiltonian for this potential given by h is equals to minus h cross square by twice m del square by del x square plus 1 by 2 m omega square x square plus g cos kx, which be equals to h naught plus h dash, where h naught is unperturbed Hamiltonian, that is minus h square by twice m del square by del x square plus half m omega square x square, and h dash is perturbed Hamiltonian g cos kx. The ground state of particle in 1DHO, one dimension harmonic oscillator, is psi 0 equals to m omega by pi h cross की power 1 by 4 e की power minus m omega x square by 2h cut. The correction in the ground state energy to the first order of G is E01 equals to psi 0 h dash psi 0 is equals to G m omega by pi h cut की power 1 by 2 minus infinity into cos kx e की power minus m omega x square by 2h cut dx is equals to g e की power minus k square h by 4m omega. So our result answer would be option D. So this problem is related to JWKB approximation. Here the energy level for a particle of mass m in the potential Vx is equal to alpha mod x. Determine a WKB approximation using this boundary condition R, where A and B are turning points. So we have to determine the energy eigenvalue using WKB approximation. Solution. The classical energy for a particle is given by E is equals to P square by 2m plus Vx. Further, so momentum will be root over 2 m into E minus alpha mod x power half. Turning point for the particle are obtained when energy of the particle comes equal to its potential energy. That is equals to Vx implies x is equals to plus minus E by alpha. So x minimum is minus E by alpha and x maximum is E by alpha. Value of left hand integral in Sommerfeld quantization rule is dx is equals to x minimum to x maximum. Here root 2m e minus alpha mod x dx, which can be written as root 2m into 2 0 से e by alpha into bracket में e minus alpha x dx. So the integral is minus root twice m into 4 by 3 alpha into e minus alpha x की power 3 by 2 limit 0 to e by alpha. So this integral further equals modified to minus root 2m 4 by 3 alpha equals to e minus e or 3 by 2 minus e की power 3 by 2 equals to minus root 2m, positive root 2m e to the power 3 by 2 4 by 3 alpha, that is p dx. वो Sommerfeld quantization condition is p dx is equals to pi h cross. So equating those to root 2m 4 by 3 alpha e की power 3 by 2 equals to n plus half pi h cut implies e की power 3 by 2 is equals to 3 by 4 n plus half pi alpha h square by 2m की power half. So e further modifies to 3 by 4 pi h cross alpha by root 2m n plus half power 2 by 3. That means our option B is correct. A particle of mass m moves in one dimension under the influence of the potential Vx is equals to minus alpha delta x, where alpha is a positive constant. The uncertainty of the product delta x delta p in its ground state is for potential the wave function of particle or such potential h psi of x is equals to m alpha by h cross square e की power minus m for x by h cross square if x is greater than 0. M alpha by h cross square alpha x by h cross square is less than 0. The expectation value and momentum operator are as the integrand is integrand in both the integral are odd function. The expectation value of x square is m square alpha square, where we have used the e to the power minus alpha x and dx 0 to infinity and factorial divided by alpha n plus 1 implies infinity x square e to the power minus twice m. That is not h. Here we have to modify it. It's in the this is not x, this is simple x. So twice alpha h cross by x is dx is equals to 2 factorial divided by 2m alpha by h का cube. This wave function is correctly defined, and here we will be having it h square. So m alpha cross x square. So here that there will be a term called h square root over m alpha h square. So we would get this term h की power 4 2m square alpha square. The expectation value of p square is average p square equals to minus h cross square minus infinity to infinity psi star x into del square psi of x but del x square dx that give us minus 2h cross square m alpha by h square cube 0 to infinity e की power minus 2m alpha x by h square dx. So which will be equals to m alpha h cross square. So the uncertainty in the position momentum r del x is equals to the product of uncertainties delta x into delta p is h square by root 2 m alpha into m alpha by h cut. That means h cut by root 2. So thus our answer C is correct for this problem. This problem is related with the variational principle. The ground state energy of a particle of mass m in the potential h square beta 6 mxc power 4. Using the normalized trial wave function, we have to determine its ground state energy. So the normalized wave function is psi of x is equals to alpha pi की power 1 by 4 e की power 2. The Hamiltonian for the given potential is h is equals to h square by twice m d square by dx square plus h square beta by 6m x to the power 4. The energy for this Hamiltonian is given by E of alpha is equals to psi of x h psi of x psi of x minus h square by twice m d square by dx square plus h square beta by 6m x to the power 4 psi of x. So this can be further simplified to minus h square by twice m psi of x square by del x square psi of x h square beta by 6m psi of x into x to the power 4 into psi of the value of these are the two inner product. First, second value of first inner product is, so we would be having psi del square psi by del x square equals to psi minus alpha plus x square alpha square psi, that means minus alpha psi plus alpha square alpha by root pi minus infinity to infinity x square e to the power minus alpha x square dx is equals to minus alpha plus alpha square plus alpha by root pi into root pi by 2 into 1 by alpha square equals to minus alpha plus alpha by 2 equals to minus alpha by 2. Similarly, the value of second inner product is psi x to the power 4. Psi x is alpha by root pi minus infinity to infinity x to the power 4 e to the power minus 2 alpha x square dx equals to 3 by 4 alpha square. Substituting the value of inner product in the expression of energy, we get E of alpha equals to h square alpha by 4m plus h square beta by 8m alpha square. Differentiating with respect to alpha, we get h square by 4m minus h square beta by 4m alpha cube equals to 0, implies alpha is equals to beta की power 1 by 3. So E minimum become h square by 4m. Substituting value of alpha in the expression of energy, 3 plus h square by 8m beta into beta की power 2 by 3. That gives us 3 by 8 m h square beta की power 1 by 3. So our answer would be option B.